So I want to hop into explaining what machine learning is using what I think is the simplest possible example. So I'm going to generate some synthetic data here where I'm generating a simple x-y relationship where y is 2 times x plus 1. So this is the equation right here for the relationship between x and y. And then I'm going to add in some noise so we can get something that's kind of realistic, because in the real world there's some signal, which is the y true right here, plus some noise in our data. And I'm going to generate this. And so the simplest ML example that I can think of is the line of best fit. So in this scenario, what I'm going to do is I'm going to plot the XY relationship that I simulated up above, and just give it a few seconds. And as you can see, there is a clear linear relationship between X and Y here, with some jitter around a straight line here because we added in some noise, but it looks to be linear. And so what I'm trying to do in this case, this is a simple linear regression example, is I'm trying to find the line of best fit to make some predictions so that if I have another X point come in, it's a new example that I pulled from the real world, and let's just say it lands here, I can make a prediction using my linear regression equation as to what y is, what the y variable is. And this could be the square foot of a house, trying to predict the price of it. That's one example. But I want to find this line of best fit. And so you may remember this equation y equals mx plus b. So y equals mx plus b, where b is going to be the intercept with the y-axis, and m is going to be the slope of that line. So I'm trying to figure out which m and b is the line that fits a line through this data that minimizes the errors. It makes the best prediction possible. So I'm going to plot, I'm going to set m and b to be what I know to be y true before I added some noise here. And I'm going to plot the line that it fits the data. And then here, these different points right here and the dashed lines are the residuals. So this right here, the true observation was x is negative 5.95 and y is 3.73. The line that I fit with y equals 2x plus 1 predicted negative 10.91 for this example. And this line right here represents that error, which is called a residual difference. And these are all the residuals for all the points. And now you can change the slope of the line. Let's say I change the slope of the line to 5. And let's see what the residuals look like. So yeah, maybe we're doing pretty good right here around x is equal to 0 in this range. But out here, we're not doing so good. The residuals have gotten bigger. And so what we're trying to do is we're trying to find an algorithm that will find the line of best fit for us. It'll change m and b like we're doing here until eventually we get to the line of best fit, the m and b, that creates the line that has the lowest error, which is going to be a matter of the error across all these examples. So it's going to be all the residuals. And essentially machine learning answers that question for us as to what that algorithm is, or how do we learn that. And so we're going to dive into the next one's going to be cost function and loss functions. How do we actually measure the error on our model? So our line of best fit, it's got all these residuals and errors across all these points. Which function are we going to use to be able to calculate the error? And we're going to use mean squared error. And I'll explain that in the next video. And then also, since we're using mean squared error, we're going to move into now, okay, how do I find the m and b in the y equals mx plus b equation to create the lowest mean squared error across the entire data set.